Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Reza Priya. I want to explain about open channel flow. The basic principle of open channel is non-pressurized flow, and second is flow whose water level is in contact with the atmosphere force. It's different with the pipe system. In pipe system, the water flow usually use pressurized flow. And the classification of open channel. The first is steady flow. In steady flow, it's divided to two types. The first is uniform flow, and the second is varied flow, gradually and rapidly varied flow. And second is unsteady flow. Unsteady flow also separate with two types. The first is unsteady uniform flow. It's rare condition to planet. And the second is unsteady flow, gradually and rapidly varied unsteady flow. First is steady flow. The flow parameter is not changed with the time parameter. So the volume or Q or H or Y is same. It's turbulent or laminar is same with the time parameter. Different with unsteady flow, the Q or the volume or the H is it will change with the time parameter. Next is uniform flow. Uniform flow is not changed with space parameter. Space parameter is like the shape of the channel. So there is no different shape of the channel. And next is non-uniform flow. It changes with the space parameter because there is uh, a different shape of the channel. So this is the figure of type of flow, type water flow. This is uniform. This is non-uniform because there is a different elevation in this view. This is uniform because it's steady and there is no different level. And this is non-uniform because this shape of channel is different. And this is the uniform. And flow condition is based on two number of this Reynolds number and Ford number. So first we want to talk about Reynolds number. In laminar flow, the effect of viscosity is greater than the effect of inertia. So the water particle is regular and straight and parallel. And for the pipe flow and laminar flow, the RA or Reynolds number is smaller than 2000. And for the open channel, the RA is smaller than 500. Next is turbulent flow. Turbulent flow, the effect of viscosity is smaller than the effect of inertia. The movement of water particles is irregular and or chaos, mixed and not parallel. The RA is more than 12,500. This the formula of fluid number. For fluid number, we can find very subcritical, critical, or supercritical flow. This is the subcritical flow, and this is supercritical flow. So there is mm, different speed of water flow because it is steady. We can say it's subcritical flow. Mm, this is not this is unsteady flow. We can say it supercritical flow. And there is category of open channel. The first is not natural channel. Example is small rivers in the upstream or area of mountains to large river in the estuary. And river usually is natural channel too. Next is artificial channel. Artificial channel is like human-made. For example, roadside drainage channel, irrigation channel, drainage channel, channels for drinking water supply, and food channels. And this is example two for artificial channel. The first is canal, second is flam or talang, three is cut or berpiring, four is drop structure or bangunan terjun, five is culvert or gorong-gorong, six is tunnel or terowongan. And this is the classification based on consistency of the shape. The first is prismatic channel. Is channel with unvarying cross-section and constant bottom slope. So the bottom slope is constant. There is no object that disrupt the water flow. For example, irrigation and drainage channel. And non-prismatic channel, yeah, built with varying cross-section and bottom slope. For example, river. In river, as we can see, there is object that disturb the water flow, for example, rock and etc. This is the classification based on geometry. Uh, channel with shape, there is a shape of weights, semi-elliptical, U-shape, secondary, horseshoe, rectangle, triangular, trapezoidal, and etc. And this is the geometry properties of some common prismatic channel. This is rectangle, this is trapezoid, and this is circle. This is the formula for finding the area, the perimeter, and top width, hydraulic radius, and hydraulic mean depth. This is other properties of optimum open channel section. Trapezoidal, rectangular, triangular, wide flat, and circle. Next is the concept of flow. There is three equation. The first is continuity, and the second is energy, and the third is momentum. This is the continuity equation, and this is the Bernoulli equation. Bernoulli equation is derived on the basis of flow along current line and Newton's second law. The assumptions needed in deriving Bernoulli's equation are considered ideal, uncompressible flow, steady flow, the velocity is evenly distributed over the cross-section. The forces acting are the compressive force, gravity, and acceleration. The sum of the compressive force, the gravity are equal to the force due to acceleration. So this is the Bernoulli equation. And this is the Bernoulli equation. This is the pressure for first pipe, and this is the second pipe. This is the energy potential energy formula. This is kinetic energy formula, and this is for specific energy formula. Yeah, this is for the example for Bernoulli equation. And this is momentum equation. We use it in flow phenomena with lots under belows so that the energy equation does not apply.